Okay, so we're going to talk about scatter diagrams and correlation. The very first thing we're going to talk about, these are scatter plots, okay? And scatter plots are made by plotting ordered pairs. And then, of course, once you plot all of your data, it could take on a shape. This one right here, this first graph, this is a positive correlation, okay? We say it's positive, of course, because it is increasing as you read from left to right. It's linear. Okay, and things that have positive correlations are, for example, the more hours you work, the more money you make if you're hourly. Okay, things like that. Then you have a linear negative correlation because as you read from left to right, it goes down. Something that you can think about is the more you work out, the more weight you lose. Or you could think of something like my bank account at the beginning of the month, my bank account at the end of the month has a negative correlation. This right here is not a linear correlation, but they are related. The relationships are related, okay? A really good example of something that would have this type of correlation is actually studying and taking an exam, the score that you make on an exam. There was a study once that said if you don't study at all, you're probably going to make a low grade. If you study too much, you're going to stress yourself out and you're cramming, so you're going to forget everything when you take the test and you're probably going to make a low grade. So you need to find that happy medium of time to study to make a high optimal grade. Here's another example of nonlinear correlation, the shape. And then of course we have no correlation. No correlation means the two things that you're studying have no relationship to one another. For example, your age and how many cucumbers you have in your refrigerator. Like there's nothing correlated. There's nothing to tell you just because you're younger you eat more cucumbers, or if you're older you eat more cucumbers, you know, anything like that. My sister's young and she is addicted to them, and then I have my brother who I think is allergic to them, so it really doesn't matter, okay? So that is basically some typical shapes that you can see when you're making a scatter plot. The next thing I want to talk about is R value. The R value is the correlation coefficient. And what this tells you, it tells you the strength of your correlation. For example, if you look at this first picture here, okay, the R value here is 1. It's exactly 1. Your R values are between -1 and 1. It can't be anything, it has to be between -1 and 1, your R value. So this is 1 because this is a perfect positive correlation, okay? It's very, very strong. It's actually, this was perfect. So what happens is, as your R value becomes lower, let's say we had 0.8, that just means that they're a little bit more spread apart. If it's still really tight, you can still see that it's positive and linear, but they're just a little bit more spread apart. 0.5 here, they're a little bit more spread apart, all the way until you get to R equals 0. If R equals 0, then that means there is no correlation. Okay? If you go the negative way, you have R equals -1. This is a perfect negative correlation. Okay? So that's -1. And then, of course, as it gets weaker, closer back to 0, -0.5, -0.4, -0.1, things like that. As it's getting closer to 0, it becomes no correlation again. But it just means the points are getting further and further away from each other. Okay? So one thing that you're going to have to do is you're going to have to be able to compare the strength of the correlations. Okay. The next thing I want to show you is that you're going to have to identify the explanatory variable and the response variable. I made it really simple. The explanatory variable is your x value and the response value is your y value. Because what happens is the response variable responds to your explanatory one and the explanatory variable explains your response. So it's kind of like the whole independent-dependent thing. This is independent, this is dependent. So the dependent variable depends on what the independent variable is doing, or the explanatory variable, okay? What's this variable doing? Whatever this variable tells it to do. So this variable explains that one, which is why we call it the explanatory variable, okay? So that is one thing that you want to do. Now, if you have a table, 99.999% of the time, this is always going to be your x value, and this is always going to be your y value. The one on the left is your x value, the one on the right is your y value. If it was this way, if the table was this way, then your x value is usually on top and your y value is usually on bottom. Now, of course, they're going to try to trick you, so you want to make sure. If we're talking about cars, weight in miles per gallon, well, doesn't the miles per gallon depend on how much it weighs? Does that make sense? How the miles per gallon depends on how much it weighs. Therefore, the miles per gallon is your y value, which is your response variable, and the weight is your x value, which is the explanatory variable. Okay, so that is something that you're going to have to identify. Okay, so the next thing that we're going to do is we're going to find the R value. I want to know the strength of this correlation. I can already tell if I plot the points that at x equals 2655, I'm at 26, and then 3180, I'm at 23, 33340, I'm at 21. So as I get bigger, my y value is getting smaller, which means this is a negative correlation. So I'm expecting my R value to be negative. But then how strong is it? Is it really close to 1, or is it further away from 1? I need to know how strong this correlation is. So I'm going to actually help you find the R value. I'm going to do it step by step. I want you to know that it is rigorous. It's a long process. If you have a TI-8384 calculator, you're going to be so excited because the calculator does it for you. But if you don't, then you're going to have to do it piece by piece the way that I'm going to do it now. Okay? The first thing you want to do is you want to make these three columns. You want to make xy, x squared, y squared. I'm trying to make it as short as I can because it's gonna. I don't want it to take up a whole bunch of space. So this is still the weight of the cars, and this was the mile per gallons. I just made them smaller. Okay. So then I made three more columns: xy, x squared, and y squared. So this xy is exactly what you think. I'm going to take this x value and multiply it by this y value and put the answer there. I get 69030, 3180 times 23. I get 73140. Go ahead and finish out the table. Okay, so here's what I got for the rest of the table. Then I'm going to go ahead and leave you to do the rest of it. This is x squared, so I'm going to take the x value and I'm going to square it. So 2655 squared. Oh my gosh, it's huge. 7049025. I'm going to need some more space. Let me get you some more space. Put y squared here. Okay, so I got 7049025. And then for y squared, I'm taking 26 and squaring it, and I get 676. Make sense? So for the second row, 3180 squared, that gives me 10112,400. And then 23 squared, I get 529. So finish out the rest of the rows. Okay, so here's the table all finished out. Hopefully I didn't make any mistakes. Okay, so then what you want to do is you want to come and add every single column. So I need the sum of all of the x's, the sum of all of the y's, the sum of all xy's, the sum of x squared, and the sum of y squared. Okay, remember that a sigma just means sum. So to add up the x's, I have 2655 plus 3180 plus 3340, 3985 plus 3680. I get 16840. Okay? Then add the sum of the y's. So 26 plus 23 plus 21 plus 18 plus 19, and I get 107. Then the sum of xy, so 69030 plus 73140, and keep going, so see what you get for the next three. Okay, so this is what I got for the rest of the sums, okay? So make note of these. I want you to write these down. Sum of x, sum of y, sum of xy, sum of x squared, and sum of y squared. Make sure you have those down because I'm going to erase this board and we really need those numbers, okay? Okay. Okay, so here's the formula. I know it's not pretty, okay? I know. We're just going to take it piece by piece, okay? This is the division sign. So in the numerator, you have the sum of xy minus the sum of x times the sum of y over n, where n is the number of points that you have. So n is the number of points that you're working with, divided by the square root. All of this is under the square root sign. So it's the sum of x squared minus the sum of x squared over n times the sum of y squared minus the sum of y squared over n, okay? And so write this down and you'll see me fill in all the components, okay? Maybe I can try to do it here. So I have r equals the sum of xy, we have that as 353,960. 353,960 minus the sum of x, which is 16840, times the sum of y, which is 107, all divided by the number of points. And we had car A, B, C, D, and E, so 1, 2, 3, 4, 5, all over the square root of the sum of x squared. This is a huge number, 577399650, minus the sum of x, which was 16840, and then we're going to square that. So that's the sum of x squared, all over n, which was 5. Close parentheses. And then under the parentheses, we have the sum of y squared, which is 2331, minus the sum of y, which was 107, squared, okay, all over 5, close parentheses. And all of that in the denominator is under the square root sign. This is what you're going to have to type into your calculator very, very carefully, okay? I would just do the numerator first. So I would have this minus this, and then write that number down. Then I would do this parentheses, then this parentheses, multiply them together, take the square root, write the number down, and then take that number divided by that number, and then there you go. Okay, so try it and see if you come up with the same answer that I do. Okay, I put in the calculator just the way that I explained, and I got r equals negative 0.989, and that is rounding to 3 decimal places. I got negative 0.989, and that's the correct answer, okay? So this is a very strong negative linear correlation, okay? It's very strong negative linear correlation. It's almost a perfect negative line. Okay, that is the only one I would have time to do. But I did want to say, even if you didn't, I did this all with my calculator, just like a basic scientific calculator. But I could have done this on an Excel spreadsheet. If you put in all the X values, all the Y values, and then for your third column, told that third column to multiply the first two together. I mean, it just really depends on how much you how comfortable you are with Excel. So then the next thing I want to do is I want to show those that have that $100 calculator what your $100 calculator will do for you. Okay, so you're going to, the very first thing you want to do is, of course, turn your calculator on, and then I want you to hit second, which is your yellow or blue button, catalog, which is the number 0. So you're going to hit second, and then catalog, which is the number 0, okay? You should see catalog right above it, okay? And then I want you to hit the number, I'm looking at mine, so I'm trying not to make any mistakes here, not the number, but the X to the -1 button. The X to the -1 button has a D above it, the letter D, and if you hit that, it should take you straight to the D's. Then I want you to hit your down arrow. You should have arrows like this. I want you to hit your down arrow until you get to diagnostic on. And where it says diagnostic on, hit enter, and then hit enter again, and it should say done. So you hit diagnostic on, you hit enter twice, and you should see done. Okay? Now what I want you to do is I want you to hit stat. We've done this before. Hit stat, hit enter for edit. Okay? If you still have something there, you want to clear out your list by highlighting the list, highlighting L1, hit clear and enter, and then highlight L2, clear and enter. Then I want you to type in all of your X values in list 1. So 2655, enter. 3180, enter. 3340, enter. And then once you're done putting all the X values in list 1, I want you to put in the y values in list 2. Okay, once you're done with that, putting them all in, I want you to hit stat again. So this is after you put in all of your values, so you put in values here. I want you to hit stat again, scroll to calc, and hit number 4. So you went to calc, hit number 4, and it should say linreg, which means linear regression, because that's what we think it has. And if you hit linear regression, you hit enter, you should see your R value, negative 0.9885. But my homework told me to round to 3 decimal places, so you get negative 0.989. So your TI-83 at 84 calculators will do regression for you, your regression correlation coefficient for you. Okay? Alright, that's it. Go ahead and try your homework and see if you have any problems. If you do, just let me know. Thanks. Bye.